with this tornado.
Yeah, it certainly does look that way. You can definitely see that swirling taking place there. So there's definitely some rotation, some broad rotation. Yeah, you're seeing the center, a donut hole here of some rotation aloft.
Oh, amazing. I think we've got a funnel now, Dr. Forbes. I'm not sure that we're going to actually see this come down to the ground yet or not, but impressive spiraling here of the atmosphere as we look northbound on a storm in Goshen County, Wyoming. We've already had one tornado form, lasted roughly 25 minutes, initially started out as a large wedge, roped out and became more horizontal, but still we've got a lot of spin here. And analyzing this area, and now I watch another area, Dr. Forbes. It's amazing, the spin is everywhere, and still watching this low-hanging protrusion that's got spin in it as well. Could we, I can't tell exactly, but could we be looking at the possibility of two different funnels trying to form here?
Yeah, I think so. You're down on the gust front that's a little bit south, I think, of where the main body of the storm is. And certainly that is a location where sometimes tornadoes will form in the shifting winds along there. Either simultaneously with the big tornado that was under the wall cloud or after that. So definitely you're right at the edge of a cloud shield there as that painting of the photo just showed.
Dr. Forbes, as I look then back off to the east, you can see the dark cloud, the anvil blow-off, that is significant. That'll extend for a very long way. When you look at the tops of the clouds and how far those extend and the base of the cloud that's kind of left behind, is the top end of the storm moving significantly faster than the bottom end of the storm near the ground?
Yes, just before we got the tornado, I had looked at that, and the anvil of the storm was 50 miles farther east than the wall cloud, the place where the tornado developed. So there is that shear today that allows the clouds to move differently at high levels aloft than at low levels, pushing the anvil farther out. And of course, that's why we have the supercell today. It is the arrival of those stronger mid-level winds and that vertical shear that has allowed this storm to have be a supercell and have a tornado.
All right, we are bringing you a one-of-a-kind vantage point round directly overhead. We've got the spin, a little bit of lowering. I got to tell you, that is scary. Look at this. You may never ever see this again, folks. This kind of vantage point of some spin of a supercell directly overhead as the entire storm itself moves southeast. That is impressive.
Yes, Mike, and the National Weather Service has put out a new tornado warning for western Banner, southeast Goshen, extreme northeast Laramie County, southeast Wyoming. They continue to track with the Doppler radar a dangerous thunderstorm that has produced a confirmed tornado, as we've been seeing. Dr.
Forbes, what's amazing to me, though, is this is almost right over top of us at the surface. The winds aren't any more than 10 miles an hour.
Yeah, you sometimes hear the expression. I think one of the viewers asked the other night about the calm before the storm. I think you're mostly in an area that's updraft now, and so you've gotten in between the outflow, and you've gotten out of sometimes what is a little jet area that's feeding into the storm, and so you're kind of in the area that's mostly just getting squeezed and going upward, and so it's a little bit of a calm before the storm type of area.
That is simply amazing. It is so close to the ground, Dr. Forbes, you almost feel like you could just reach up and touch it, and hardly any rain at all. Just a few spits of rain, that is it. And this really looks like the back edge of the storm now as the entire system now pushes off more to our east. Although now I start to see more flow in, Dr. Forbes, from the east as that storm moves east. So it looks like we've got converging air a little bit right in this area right here. And now I feel the winds pick up significantly.
Yeah, and I can hear it in your mic that the winds have picked up. What direction do you think those winds are from, Mike?
I'm sorry, say again?
I can hear it, the wind in your mic. What direction do you think the winds that you're getting are from?
Right now the winds are from the, I would say, northwest are our winds right now at our vantage point, and we are looking basically due north.
Yeah, so you've gotten into the gust front has just passed, and you're getting that deck of clouds that is being lifted up right over top of that gust front. And it's kind of what we tell the viewers, that the gusty winds occur right at the leading edge of water shelf clouds. Now this is not the shelf cloud that is usually associated with a squall line. This is the rear flank downdraft, but it's the same kind of thing. The strong winds occur right under the edge of that band.
What has been amazing is that we have witnessed multiple areas of tight spin within this supercell, Dr. Forbes. We saw one that came down to be a tornado, but I think in a lot of our minds, one supercell has one rotation, one tornado, and that is it. But I have witnessed at least half a dozen different tight spirals within in this supercell itself.
Yeah, this storm is occurring in an environment with lots of change of wind with height, and so every place where it finds a little bit of a pocket of updraft, it can begin to tilt that those horizontal rolling motions of the atmosphere up into vertical. And so every time it forms a little bit of a pocket of updraft, it gets a new little pocket of spin, maybe one of those going right about there. Truly amazing as we witnessed the entire life cycle of a tornado here in Goshen County, Wyoming, as a supercell thunderstorm produced a tornado that was on the ground for roughly 25 minutes and then roped out and dissipated. Now we're on the back edge of the storm, and basically the heart of the storm has passed us by now. And Dr. Forbes, at one point, it did take a right turn, and it was heading more southeast than east, but as I look at it now, I'm not sure that it's heading more east than south at this point. Yeah, I think it's heading due east. Mike, give us a little bit of a recap now of how the weather that you're feeling has changed in terms of the temperature and how have the winds changed.
You know, pre-storm, Dr. Forbes, we had hardly any wind. We had a vantage point of several miles off to our northwest. We had a huge vantage point of the supercell, lowering wall cloud, and that is where we saw the tornado form. It was very warm, it was very calm. We could witness the hail shafts, the rain shaft, and the tornado itself. Now things have significantly changed. Now we've got a little bit of rain coming our way. Now we've got a strong northwest wind that's coming our way as the entire storm has passed us by now. We're basically on the back edge of it, and you can see the entire thing is blown off to our east right now, and it seems like now we don't have nearly as much rotation in this part of the storm as we had right in the heart of it and pre-storm, Dr. Forbes. So I'm interested to see, because the stick nets were on this road deploying in a north-south fashion every 2 miles. You were talking about the temperature data, how key that could be. Physically, I can feel how much colder it has gotten, and that is a cold driving rain that is hitting us right now.
Yeah, you're exactly right, Mike. So I think for a while there, the downdraft wasn't so cold, but obviously now it's getting pretty cold, and at that point I think it choked off the tornado. So that being one of the key questions that Vortex 2 wanted to answer was, how did temperature of the downdraft and that outflowing air, how would that affect the ability or inability?
Oh, that Dr. Forbes, wow, this rain feels just like hurricane wind-driven rain. And these are obviously the most significant winds that we've seen. What causes the supercell winds on the backside to be the strongest?
Yeah, in this area, there's your rear flank downdraft in action, Mike. That rain-cooled air is wrapped all the way around the west side and now to the south side, and now it's coming east toward you. You're in the outflow that has come down around on that rear flank of the storm.
Very good, Dr. Forbes. We've got another vantage point of you. We've got a live streaming camera with our embedded journalist, Katie Turr, and you're witnessing hail within this as well. As far as hail size, Dr. Forbes, what can determine hail size? And just like that, our rain is gone.
Well, the hail size, how big hail can get, is largely determined by how intense the thunderstorm updrafts are, because the hail is sort of levitated aloft. It's suspended there by the updraft, just joggling around, adding new growth layers on top of it until it gets so big it falls out. So the stronger the updraft of the storm, the bigger the hail. And certainly we've seen the record is about 7-inch diameter kind of hail. And I haven't seen, Jess, have we had any hail reports from this storm? Earlier I had seen, before we came on air here, I had seen some 1-inch hail had been reported in the early stages of the storm.
Right. Dr. Forbes, when we watched the tornado itself form, and especially on the north side, that is where we saw what we thought were probably some of the most intense downdrafts within that hail, because we need a strong updraft to support it, and then it comes down in those downdrafts on the north.